We're now going to find the magnitude and the direction of a vector when it's given in component form or column form. We must draw a sketch first. So we're going to rule vertical and horizontal axes. The vertical axis, remember, is now the j-axis, and the horizontal axis we call the I-axis, and then mark the position of the origin. Now, in order to draw this vector, we always choose its tail to be on the origin. So plot a point on the origin, that is going to be the tail of the vector. The I and j components of the vector tell us how we get from the tail to the nose of the vector. So the I component here is -6. So that means we're moving 6 units to the left. So we're going to be on -6. The j component is -4. So that means we then have to move 4 units down. And then we will finish at the nose. So once we've got the tail and the nose plotted, we then join them with a straight line, and that is going to be the actual vector. We must put an arrow on the vector, and the arrow always points at the nose. So we've now sketched the vector. What we now do to help us answer part A and B is we now form a right-angled triangle such that the horizontal axis and the vector itself are 2 of the 3 sides. So we're going to draw the third side here, and the third side is going to connect the nose to the horizontal axis. Like that. Now we're going to write down the horizontal distance between the nose and the tail, and we're going to write down the vertical distance between the nose and the tail. So the horizontal distance is just going to be 6 units. Remember, when we're talking about distances, we ignore negatives. And the vertical distance between the nose and the tail is just going to be 4 units. Again, you ignore negatives. We also need to put the direction in our sketch. Now remember, the direction is given by the angle theta, and theta is always measured between the vector and the horizontal axis. So theta is going to be in here. Okay, so we're now ready to get the magnitude in part A. So part A, I'm going to show you 2 methods we can get the magnitude. I'm going to get the magnitude directly from the sketch. So magnitude from the sketch. Okay, so the magnitude, remember, is the length of the vector. So we're just going to use Pythagoras' theorem. So the hypotenuse, remember, is the magnitude of vector r. So the hypotenuse squared is equal to the sum of the squares of the other 2 sides. So it's going to be 4 squared plus 6 squared. So that's going to give us 16 plus 36, which is going to give us 52. We're then going to take the positive square root, so we're going to get the magnitude of r is equal to the positive square root of 52. Now, It says to give our answer exactly. So first of all, yes, it is exact. It's got a square root, but it can be simplified. The largest square number that goes into 52 is actually 4. So it's actually 4 times 13. So we can break it up and write it as root 4 times root 13, which is going to give us 2 root 13 units. So that's our answer for the magnitude using Pythagoras directly from the sketch. Now the other way we could get the magnitude is just using the formula. So magnitude using formula. So remember, the formula is the magnitude of r is equal to the square root of the I component squared, so x squared, plus the j component squared, so that's just y squared. So the vector that was given in the question was r equals minus 6i minus 4j. So we're just going to get the magnitude directly without using a sketch. So magnitude of r is going to be the square root of the I component squared, so that's minus 6 all squared, plus the j component squared, that's minus 4 all squared. And again, if we tidy that up, minus 6 squared is going to give us positive 36. So we're going to be left with 36 plus minus 4 squared is just positive 16. So 36 plus 16 is going to give us root 52, which we had before. And again, that's just going to give us 2 root 13 units as before. So you can either get the magnitude from the sketch or you can get the magnitude using the formula. Now, some people might argue and say, well, why bother doing the sketch if you can get the magnitude without using the sketch? Well, in part B, we need to get the direction. So that's why it's important we draw the sketch. If we're going to get the direction and it asks us for the magnitude, we may as well use the sketch to get the magnitude and the direction. Okay, so part B, we're looking for the direction. So remember, the direction is given by the angle theta. So if we look inside our right angle triangle here, we're going to use right angled trig. We know the adjacent, we know the opposite. So opposite and adjacent means we're going to use tan. So we're going to use the tan formula. So tan theta is equal to opposite over adjacent. And that's going to be equal to, so the opposite side is 4, the adjacent is 6. So that's 4 over 6. And then we're going to take the inverse tan of the other side. So if we go to our calculator, make sure we're in degree mode. So shift tan 4 over 6. And that's going to give us 33.69. And then we have to give it to 3SF, so that's going to give us 33.7 degrees to 3SF. Now we're still not done because, yes, we've worked out the angle, but we need to specify where the angle is. So if we go back here to our sketch, the angle is measured down from the negative y-axis. So obviously this is the negative y-axis, so we need to say that the angle is 33.7 degrees and it's below the negative y-axis. So final answer then for that bit is direction is 33.7 degrees below the negative y-axis. You could also say x-axis. but you have to specifically indicate where the angle is. It's okay finding it, but in this case it's below the negative x-axis. It could also be above the negative x-axis, it could be below the positive x-axis, it could be above the positive x-axis. So just be careful, don't just work out the angle, also specify exactly where it is relative to the horizontal axis.